Imagine you are a free diver. You are 200 feet underwater. The pressure is immense, the light is super dim, and suddenly your brain starts absolutely screaming at you to breathe.
Oh yeah, pure panic.
Exactly, your chest convulses. Panic just totally floods your system. And I mean, the overwhelming assumption there is that your body is terrified because it's running out of oxygen. That's what we've all been taught, right?
It seems totally logical.
But what if I told you that your brain isn't panicking about oxygen at all? Like, it's actually reacting to a hidden ancient alarm system in your brainstem that measures something entirely different.
Which is wild to think about.
It is. And what if I told you that by hacking that specific biological alarm, elite performers, from ultra-endurance athletes to Navy SEALs, can literally remap their brain's response to the most terrifying things in life?
That is the core of it, really.
Because we live in a culture right now that is just obsessed with mindset. I mean, we are bombarded with this idea that if we just think positive thoughts or journal our way through a crisis, we can logic our way out of panic or exhaustion or grief.
Yeah, the whole just change your thoughts movement.
Right. But when you are standing on the edge of a cliff or you've just received a devastating phone call, telling yourself to just be calm is a joke.
Well, it is worse than a joke, honestly. It is a physiological impossibility.
Wow.
Impossible.
No.
In those extreme states, trying to use your conscious, rational mind to calm down is, it's like trying to put out a forest fire with a squirt gun.
A squirt gun, that's a great image.
Right. Because we place a tremendous amount of faith in our forebrain, the logical reasoning center of our consciousness. We sort of think we are software programs that can just be debugged with a new line of code.
Just run an update and fix the anxiety.
Exactly. But we forget that beneath that thin veneer of logic is an ancient, heavily armored biological machine that, quite frankly, doesn't speak English.
It doesn't care about your journal.
It does not care at all. It speaks in hormones, neurotransmitters, and electrical impulses.
Okay, let's unpack this, because our mission today for this deep dive is to completely decode that machine. We are looking at a stack of research on how the top 1% of performers manage to conquer the hardest human experiences. Fear, exhaustion, trauma.
The real heavy hitters.
Yeah. And the secret here is that they do not control the mind with the mind. They actually use the physical body as a lever to violently shift the mind.
That's the paradigm shift.
So we are going to explore the autonomic nervous system today, not as some abstract medical concept, but as a tangible physical control panel. We're going to give you, the listener, the specific tools to build a biological tolerance to stress. We'll look at why your vision literally changes when you panic and how to survive the neurological shockwave of grief.
And the foundational shift for you listening is realizing that the autonomic nervous system operates as a continuum. We often hear it described as a seesaw, but I think a better visualization is a complex mixing board in a recording studio.
Like with all the different sliders.
Exactly. On one extreme end of the sliders, you have maximum alertness, so panic, terror, explosive action.
Right.
And then on the other end, you have profound parasympathetic calm. That's the state of cellular repair and deep sleep. And this system wires into every major organ, your gut, your heart, your pupils.
Everything is connected to the board.
Everything. Now, the traditional view was that this system was entirely automated, like completely out of our control. But modern science proves that it is actually a bidirectional street.
Meaning it goes both ways.
Right. Your brain can send a panic signal down into your body, sure. Yeah. But you can also deliberately execute physical bodily behaviors that force a signal back up the spinal cord.
You can physically grab the sliders.
Yes. You grab the sliders on that mixing board and yank them back to calm.
Man, before we can start yanking those sliders, though, we really need to understand the anatomy of the panic itself. Because it's one thing to say, I feel stressed, but it's another to actually look under the hood and see the mechanical cascade that traps us there.
Yeah, let's trace the actual biological sequence, because the moment you perceive a threat, and it does not matter if that threat is a physical predator in the woods or an incredibly hostile email from your boss.
Both feel like life or death in the moment.
They really do. Your body runs the exact same evolutionary script. The hypothalamus, which acts as the central dispatch center in the brain, it sounds the alarm.
Okay.
And within milliseconds, before you've even consciously processed the words in that email, your internal logistics are being radically reorganized.
It's essentially declaring martial law on your internal organs.
That is a perfect way to look at it. The body knows that surviving a threat requires explosive physical energy, so it immediately shuts down long-term projects. Well, blood flow and metabolic energy are forcefully routed away from your digestive tract, for one.
Oh, wow.
Because digestion is a highly energy-intensive process. And if you are about to be eaten, absorbing the nutrients from your breakfast is completely irrelevant.
Yeah, that makes sense. You don't need to digest a bagel if you're running for your life.
Exactly. The reproductive system is similarly suppressed. And at the same time, the liver gets a signal to dump massive amounts of stored glucose, which is pure operational fuel, directly into the bloodstream.
And where does that fuel go?
It is shuttled straight to the large muscle groups, the quads, the hamstrings, the shoulders.
So you are primed for violence or a dead sprint. Which, actually, this brings up something I've always wondered about. Whenever I have to give a major presentation, or, if I get into a really heated argument, my hands start shaking.
Yes.
And sometimes my voice quivers. I always viewed that as a sign of weakness, like my body was just completely failing me in the moment. But the sources we're looking at suggest the shaking is actually a sign of the system working perfectly.
It is. The shaking is literally the physical manifestation of trapped kinetic energy.
Trapped energy.
Think about what is happening on a cellular level right then. Your muscles are flooded with glucose. Your heart rate is massively elevated, right? Pumping highly oxygenated blood to your extremities.
Yeah.
Your nervous system is screaming at you to run or fight.
Yeah.
But what are you actually doing? You are standing perfectly still behind a podium or sitting rigidly in a chair across from your partner.
I'm trying to look totally calm while my biology is begging for action.
Exactly. The shaking is the mechanical consequence of applying the brakes while the accelerator is pinned to the floor.
Oh, man. That is such a good analogy.
The RPMs of your biological engine are cranked to the red line and you're sitting in park. The engine blocks of your muscles are literally vibrating from the unspent potential energy.
Wow.
This is actually why animals in the wild, after escaping a predator, they will violently shake their entire bodies.
I've seen that, like a dog shaking off water.
Right. They are discharging the autonomic arousal. Humans, though, governed by social norms, we suppress it, which traps the arousal inside the nervous system.
So when I feel totally overwhelmed at my desk and I suddenly have this aggressive urge to just, go for a run or even just pace furiously around my office, that isn't a distraction. That is my body demanding I burn off the glucose. It's just prepared for me.
Exactly. It's demanding you put the car in drive.
But the physical changes aren't just in the muscles. The scariest part of this stress cascade is what happens to our perception of reality. Our vision literally changes.
It does, and it happens through a truly fascinating mechanism. When the sympathetic nervous system activates, it triggers the dilator muscles in your irises. Your pupils expand dramatically.
Right. And intuitively, we assume that larger pupils would let in more light and, give us a wider, more comprehensive view of our surroundings. Like we think we'd want to see everything to spot the danger.
That would make sense, but the optics actually do the exact opposite.
The optics are totally counterintuitive.
Totally. Because of how the lens of the eye focuses light onto the retina, when the pupil dilates significantly, the aperture of your visual field physically narrows.
You lose your peripheral vision.
Yes. It creates a phenomenon known as the soda straw view. You are literally looking at the world through a tightly constricted tube.
So you become hyper-fixated on whatever's directly in front of you.
Right. The trade-off is that while you lose the periphery, your visual acuity for the specific object of your focus becomes exquisite.
Like high definition.
Exquisite high definition. You can detect micro-movements, slight shifts in light, tiny details of the perceived threat. Your brain dedicates all visual processing power to the thing that might kill you.
But the soda straw isn't just a visual trick. The sources explicitly point out that this physical narrowing causes a cognitive narrowing. And this is the part that terrifies me.
The mental soda straw.
Yes, because your visual field and your cognitive field are deeply intertwined.
Deeply. When your vision narrows to a single point, your thinking also collapses into a highly restricted aperture. Your brain drops into a rigid algorithmic loop of if this, then that. You become obsessively locked onto the stressor.
Right, you get trapped in future tripping. If I fail this presentation, I lose my job. If I lose my job, I lose my house. Or you get sucked into the past, just agonizing over why you didn't prepare more. But you literally cannot see the peripheral solutions.
And that is the tragedy of modern panic. The solutions to our modern stressors usually require lateral thinking.
Right.
If you are stressing over a financial problem, the solution might involve calling a mentor, or maybe going for a walk to clear your head, or drafting a new budget. But because your cognitive aperture has narrowed into a soda straw, those peripheral solutions are completely invisible to you.
You just can't see them.
The very behaviors that would regulate your nervous system are blocked from your awareness.
Okay, I have a major pushback here, though. From an evolutionary standpoint, how is this massive cognitive flaw adaptive? Like, if early humans panicked and suddenly couldn't think laterally, how did we survive? It sounds like a design failure.
Well, we survived specifically because of this design.
Right.
You have to contextualize it within our ancestral environment. For hundreds of thousands of years, acute stress meant a physical predator was charging at you.
Okay.
If a tiger is leaping from the brush, you do not want your brain accessing peripheral creativity.
Well, you don't want to be designing a new spear in that moment.
Exactly. You shouldn't be brainstorming novel ways to arrange your cave, and you certainly shouldn't be admiring the sunset in your peripheral vision. You need your entire visual, cognitive, and physical being locked onto the teeth of the tiger, utilizing that glucose to sprint in the opposite direction.
So the system is flawlessly designed for physical survival, but it is disastrously misaligned with modern psychological stress. We have caveman hardware trying to process software updates. When the tiger is just a realization at 2 a.m. that you forgot to pay your taxes, the soda straw effect traps you. You can't sleep, which spikes your heart rate, which narrows your aperture further, and all you can focus on is the fact that you aren't sleeping. It's a completely self-consuming loop.
A completely self-destructive loop. And if we want to understand how elite performers break this loop, how they conquer this system, we have to look at what happens when you intentionally push human biology to its absolute breaking point.
We have to examine the ultimate universal panic trigger.
Which brings us back to the freediver at the bottom of the ocean.
Right. Because when we look at the hierarchy of human fears, we all have our subjective terrors. Some people hate spiders, some are terrified of heights or public speaking. But if you want to find the biological bedrock of panic, the fail-safe that makes every single human nervous system explode, it is carbon dioxide.
Carbon dioxide is the ultimate trump card of the autonomic nervous system.
The trump card.
Yeah. You can have a monk with decades of meditation experience, or the most hardened special forces operator. But if you manipulate their CO2 levels, you can bypass their conscious control entirely and induce raw panic.
See, I always thought the drive to breathe was oxygen-driven. I assumed that if I held my breath, my brain had some sort of internal fuel gauge, and when the oxygen needle hit empty, the panic started. But the research completely debunks that.
It is one of the most pervasive misunderstandings of our own biology. We do not possess an internal oxygen gauge in the way you describe.
We don't.
No. There are no neurons in the brainstem that fire simply because oxygen is depleting. Instead, your drive to breathe is governed by chemoreceptors located deep in the brainstem. These specialized neurons function as an alarm system exclusively monitoring the acidity of your blood.
And the acidity is tied to the CO2.
Directly tied to the buildup of carbon dioxide.
So it's not the absence of the good stuff, it's the presence of the exhaust.
Precisely. As your cells metabolize energy, they produce CO2 as waste. When you hold your breath, that CO2 accumulates in the bloodstream.
Okay.
When the concentration of carbon dioxide crosses a very specific, hardwired threshold, those chemoreceptors fire. And they don't just, politely suggest that you breathe. They trigger a violent, involuntary reflex.
The gasp reflex.
Yes.
It overrides everything. Your diaphragm spasms, and you are forced to inhale, even if you are underwater, which makes what freedivers do seem almost supernatural. I mean, they are diving hundreds of feet down on a single breath. How are they not triggering this alarm?
They train to chemically hack the alarm system using a technique called cyclic hyperventilation. Sometimes it's referred to as air packing.
Air packing.
Yeah. Before they ever enter the water, they take a series of deep, forceful, rapid exhales.
They are blowing off the exhaust.
Exactly. They are massively offloading carbon dioxide from their bloodstream, artificially driving their CO2 levels down to a baseline far, far below normal.
So when they finally take that last deep breath and dive, they aren't just loaded with oxygen. They have bought themselves massive amounts of time before the CO2 can build back up to the critical alarm threshold.
They have essentially moved the starting line back. Yeah. Because their CO2 begins at such an artificially low point, they can stay submerged for extraordinary durations before the gas accumulates enough to trigger the brainstem's chemoreceptors. But And this is a big but. This extreme biological manipulation introduces a terrifying vulnerability.
Because they are turning off the only alarm system that tells them they are dying.
That is the grim reality of shallow water blackouts and freediving fatalities.
Yeah, that's so dark.
When an amateur holds their breath, they panic and thrash to the surface long before they actually run out of oxygen because their CO2 alarm triggers early. But when world-class elite freedivers die, it is usually remarkably peaceful.
Peaceful?
Yes. They have offloaded so much CO2 and built up such an immense psychological tolerance to the remaining buildup that the alarm threshold is never reached.
The CO2 never triggers the gasp reflex.
It never triggers. Meanwhile, the body continues to consume the finite supply of oxygen. The oxygen simply depletes, the brain is starved of fuel, and the diver peacefully loses consciousness. The lights just go out.
Wow.
The very expertise they developed to override their primal biology becomes the mechanism of their demise.
It's the danger of completely muting your internal feedback loops. It actually reminds me of the phenomenon in expert skydivers. The sources noted that highly experienced skydivers, people with thousands of jumps, sometimes die simply because they forget to pull the ripcord.
It's a fascinating parallel. A novice skydiver is flooded with sympathetic arousal.
Yeah.
The hypothalamus is screaming, the adrenaline is pumping, the fear of gravity is absolute.
They are hypervigilant.
Exactly. But an expert who has jumped 5,000 times has fundamentally rewired their autonomic response to freefall. They have habituated to the environment to such an extreme degree that the primal fear is entirely extinguished.
So they just get distracted.
They get distracted, they feel comfortable, and they lose the essential signal that keeps them alive.
This raises an important question then. The desensitization becomes the vulnerability. But speaking of gravity, there's another biological hardwiring that blew my mind in the research. We talk about CO2 as a universal chemical trigger, but there is also a universal visual trigger.
Right.
We've all seen those insane videos of teenagers hanging by one hand from a skyscraper under construction hundreds of feet in the air. I can sit perfectly safe on my sofa, watch a 5-inch screen, and within 3 seconds, my palms are dripping with sweat, my heart is hammering, and I feel nauseous. How can pixels on a screen hijack my autonomic nervous system so violently?
To understand that, you have to realize that human beings are overwhelmingly visual creatures. Upwards of 40% of our cerebral cortex is involved in processing visual information.
40%, that's huge.
It is, but even more foundational than that, consider the very first universal force every single human infant learns to navigate. From the moment you try to lift your head or take your first step, you are constantly computing gravity. You learn intimately that things fall down.
The brain has a deeply embedded physics engine.
A deeply embedded, highly protective physics engine. And when you watch a video from the top of a skyscraper, your visual cortex processes the extreme depth of field. It registers the special orientation aligning with the gravitational pull.
Okay.
And because your visual system is so deeply integrated with your survival mechanisms, your brain doesn't just passively observe the video, it aggressively simulates the reality.
It physically prepares me to fall, even though I'm sitting down.
Yes. Down at the base of your skull is the cerebellum, which literally translates to little brain. It handles fine motor control, balance, and proprioception.
Right.
When the visual cortex feeds it that extreme depth data, you experience microactivations within the cerebellum. The circuits that govern the falling reflex begin to fire. Your brain perceives an imminent fatal drop and immediately triggers the hypothalamus to dump adrenaline.
Which explains the nausea.
Yes. It shunts blood from your digestive system, hence the nausea, and causes your palms to sweat.
Why the sweat, though?
It's likely an evolutionary adaptation to improve grip. The visual input completely bypasses your conscious logic.
So whether the trigger is chemical, like carbon dioxide, or visual, like perceived gravity, or even psychological, like the fear of public speaking, does it all run through the exact same biological hardware? Is it all the same panic?
Yes, and that is a crucial realization. While the triggers are completely subjective and dependent on your context, the internal physiological cascade funnels through a final common pathway.
It's the same pathway every time.
Every time the threat is detected, it runs through the amygdala, which is the brain's threat assessment center, and structures like the stria terminalis, which heavily influences our anxiety and stress responses.
I want to pause on the stria terminalis, actually, because that comes up in a lot of neurohacking circles, but rarely gets explained well. What is it actually doing?
Think of the amygdala as the smoke detector. It senses the immediate, acute threat, the loud bang, the sudden movement.
Okay, the immediate alarm.
Right. The studia terminalis is a band of fibers that acts more like the prolonged anxiety dial. It takes the initial alarm from the amygdala and projects it to other brain regions, sustaining the state of hyperarousal and dread over time.
Oh, I see.
It's the difference between the jump scare of a horror movie, that's the amygdala, and the creeping, agonizing suspense of walking down a dark hallway. That's the stria terminalis.
That makes perfect sense. So both the acute smoke detector and the sustained anxiety dial ultimately route their signals to the hypothalamus.
Correct. The hypothalamus, sitting just above the roof of the mouth, acts as the general issuing the orders. It takes the panic signal and translates it into a body-wide autonomic explosion. It commands the adrenal glands to release epinephrine, adrenaline, and cortisol.
Which brings us to the most important question of this deep dive, I think. If this biological fear response is so deeply wired, so ancient, and so overpowering, how on earth do elite performers function inside it?
That is the million-dollar question.
Right. How does a Navy SEAL or a high-stakes surgeon operate when their hypothalamus is flooding their brain with terror chemicals? Do they just not feel the fear?
Oh, they absolutely feel the fear.
They do.
Oh, yeah. The difference is not the absence of the chemical cascade. The difference is their relationship to the friction it creates. To illustrate this, the research highlights David Goggins.
Oh, man. Goggins is legendary. Former Navy SEAL, ultra-endurance athlete, known for his extreme mental toughness.
Right, and Goggins participated in a neuroscience study at Stanford led by Dr. Andrew Huberman. They placed Goggins in a virtual reality environment designed to evoke intense phobias.
They put him in a VR shark cage.
Yeah.
And despite being a SEAL who has conquered some of the hardest physical training on Earth, Goggins is genuinely terrified of sharks.
He hates them.
Yeah.
The researchers assumed he would avoid it or rely on some complex visualization to calm down. Instead, Goggins actively sought it out. He demanded to go into the shark simulation precisely because he hated it.
Because he hated it.
Yes. He was hunting for the biological resistance. This introduces the core concept of elite resilience. Limbic friction.
Limbic friction.
The invisible wall.
It is the measurable internal resistance you experience when your conscious goals are in direct conflict with your autonomic nervous system.
Like waking up early.
Exactly. Limbic friction is the intense effort required to drag yourself out of a warm bed at 4:30 a.m. to train when your parasympathetic system is demanding sleep.
Yeah, we've all felt that.
But it is also the massive cognitive effort required to sit completely still and perform complex mental math while your sympathetic nervous system is flooding you with adrenaline and screaming at you to run. It is the friction of opposing your own biology.
So when Goggins puts himself in a terrifying VR scenario, he isn't trying to become unafraid of sharks. He is deliberately spiking his adrenaline just so he can practice operating his mind while inside the chemical storm.
Exactly.
Because, and this is a massive paradigm shift for me, adrenaline is totally generic, isn't it? This is one of the most liberating facts of human biology. Epinephrine adrenaline is a highly generic, non-specific molecule. Your body does not manufacture a special public speaking adrenaline that is chemically distinct from car crash adrenaline or shark attack adrenaline.
It's all the exact same juice.
It is all the exact same molecule. It is synthesized primarily in the adrenal glands and in a small, powerful cluster of neurons in the brainstem called the locus coeruleus.
So the locus coeruleus acts like a chemical sprinkler system, just spraying the brain with wakefulness and agitation.
That is a great analogy. The locus coeruleus projects its axons widely throughout the brain, and when it fires, it wakes the entire cortex up. It creates the sensation of urgency and agitation. But because the chemical is generic, the tolerance you build to it is also generic.
Here's where it gets really interesting. This is the hack. It's exposure therapy for limbic friction. If an elite performer can teach themselves to stay calm, control their breathing, and think logically while their body is being flooded with adrenaline from a VR shark or an ice bath, they will have that exact same neurological circuitry available to them when a business deal collapses or a medical emergency happens. They are raising their baseline tolerance for epinephrine in the brain.
But the crucial variable here, the thing that determines whether the stress traumatizes you or strengthens you, is agency.
Agency.
There is a profound neurobiological difference between stress that happens to you and stress that is evoked by you.
Wait, really? If the adrenaline is the exact same chemical, why does the brain care who started the cascade?
Because of the neural pathways that are co-activated. When you are unexpectedly pushed into a freezing river or you are surprised by a predator, You are entirely at the mercy of the limbic system. You are a victim of the chemical flood.
You're just reacting.
Right. But when you choose to step into an ice bath, or you choose to confront the VR shark, your prefrontal cortex, the center of executive function, logic, and voluntary action, is highly engaged.
You are intentionally overriding the panic.
By willfully leaning into the limbic friction, you are teaching your brain a vital lesson. Even when I am flooded with panic chemicals, I still have options. I still possess agency. You are wiring the prefrontal cortex to exert top-down control over the amygdala.
So you are not just surfing the chemical wave, you are learning to steer the board.
Precisely.
That completely reframes the idea of toughness. It's not about suppressing emotion, it's about familiarizing your forebrain with the chemical state of panic so it doesn't shut down when the alarm rings.
Yes.
But, I have to ask on behalf of everyone listening, we don't all have access to a VR shark lab, and most of us aren't going to jump out of helicopters to fight wildfires to build this resilience.
Probably not.
So how can a normal person create this self-evoked adrenaline in their daily routine? What is the accessible toolkit for autonomic regulation?
The most potent, universally accessible tool for generating massive adrenaline release and practicing top-down control is deliberate cold exposure.
The cold plunge. It has become a massive trend, but the research shows it's not just a fad. It's a direct biological lever you can pull every single morning.
It is remarkably reliable. Water conducts temperature away from the body roughly 25 times faster than air.
25 times.
Yeah. So when you submerge yourself in cold water, you instantly and violently crank the sympathetic nervous system to its maximum output. The locus coeruleus fires, the adrenals dump, and you experience a massive spike in epinephrine.
Boom. Instant panic.
Instant friend. But the key to utilizing this isn't just suffering for the sake of suffering. There is a specific, scientifically backed protocol known as the Soberg principle.
Named after the researcher Dr. Susanna Soberg. What are the specific parameters? Because I think people assume you have to sit in a frozen lake for an hour to get the benefits.
The barrier to entry is actually much lower than people fear. Dr. Soberg's research found that you only need a minimum total of 11 minutes of uncomfortable but safe cold exposure per week to trigger profound metabolic and psychological adaptations.
Just 11 minutes total for the whole week.
For the whole week.
So I could do 3 minutes on Monday, 4 minutes on Wednesday, and 4 minutes on Friday.
Exactly. You fractionate the exposure, and by hitting that threshold, you induce massive autonomic regulation, but you also stimulate the growth of brown adipose tissue or brown fat.
Okay, I need you to explain brown fat, because we hear about it constantly in wellness circles, but it sounds paradoxical. How does growing more fat make you metabolically healthier?
It comes down to cellular function. The white fat that most of us are familiar with acts primarily as an inert storage locker for excess energy.
Right, the stuff we usually want to lose.
Right, but brown fat is entirely different. It gets its darker color because it is densely packed with mitochondria, the power plants of the cell. Brown fat does not store energy, it burns it.
It burns it.
Its primary biological function is thermogenesis, the generation of heat.
Like an internal furnace.
A furnace that utilizes your stored energy to keep you warm. Regular, deliberate cold exposure forces your body to recruit and build more brown fat, which increases your resting metabolic rate and makes you fundamentally more resilient to physical and psychological stress.
But what if someone listening says, look, I don't own an ice bath, and the tap water in my apartment only gets down to maybe 60 degrees Fahrenheit. Can they still get the benefits?
Yes, the physiological math balances out, but it requires a trade-off in time.
How so?
Well, if you plunge into 40-degree water, you might only need 2 or 3 minutes to trigger the maximum catecholamine response, the adrenaline and dopamine spike. If your water is a relatively mild 60 degrees, you can achieve the exact same chemical peaks, but it will require significantly longer exposure, perhaps 45 to 60 minutes.
An hour in a cool bath actually sounds vastly more miserable than 3 minutes of pure agony. I'll take the ice.
Many people agree with you on that.
But there is a critical rule in the Soberg principle regarding how you finish the exposure.
Yes.
Yeah.
The rule is that you must always end on cold. End on cold. If you are utilizing contrast therapy moving between a hot sauna and an ice bath, your final exposure must be the cold water. And crucially, you should not immediately jump into a hot shower or wrap yourself in a heavy heated blanket.
Why not? The instinct is immediately to find warmth.
Because if you artificially warm yourself up, you short-circuit the adaptive response. By getting out of the cold water and forcing yourself to air dry or shiver, you force your autonomic nervous system to do the heavy lifting.
You're making it work for it.
Exactly. You demand that the brown fat activate and the metabolic furnace turn on to reheat your core from the inside out. You are training the biology to regulate itself, rather than relying on an external crutch.
We mentioned the sauna just now, and the sources dive into heat exposure as well. If cold is a massive sympathetic spike, extreme heat has its own intense protocols, particularly for recovery.
Sauna use is exceptional for vasodilation and cardiovascular health. But if a listener is looking to tap into extreme physiological adaptation, specifically regarding endocrine changes and the release of human growth hormone, there is a highly specific, intense protocol.
Walk us through it.
It requires completing 4 30-minute rounds in a sauna heated between 187 and 212 degrees Fahrenheit, all within the same day, taking only 5 to 10-minute cooling breaks between rounds.
That is 2 full hours in a 200-degree box. That sounds borderline dangerous if you aren't prepared for it.
It is a severe, exhausting stressor, and it must be approached with extreme caution and hydration. But the biological response to that specific threshold of heat stress is astonishing. Research has shown that executing this extreme protocol just once a week can increase the release of human growth hormone up to 16-fold.
16 times the normal output. Right, really? How is heat triggering a growth hormone?
It is largely mediated by heat shock proteins. When your cells are exposed to extreme thermal stress, they synthesize these specific proteins to protect their structural integrity and prevent cellular misfolding.
Okay.
This massive systemic stress response cascades through the endocrine system, signaling the pituitary gland to dump growth hormone to facilitate rapid cellular repair and recovery. Whether it is extreme cold or extreme heat, you are utilizing an environmental stressor to force a beneficial biological adaptation.
But the benefits of the cold plunge aren't just physical. The sources suggest it acts as a reliable, mechanical antidepressant. And this brings us to a monumental shift in how we need to understand our brain chemistry. We've been talking about adrenaline, but cold exposure triggers a massive release of another chemical, dopamine.
Dopamine is arguably the most misunderstood molecule in popular culture.
Totally. We hear dopamine and we think of the pleasure of eating a glazed donut or the quick hit of seeing 100 likes on an Instagram post. We think it's the reward.
And that framing is deeply inaccurate. Dopamine is not the molecule of pleasure, reward, or satisfaction.
It's not.
No, serotonin is the molecule of satisfaction, the feeling of being content with what you currently possess, enjoying the present moment, and being at peace in your immediate sphere. Dopamine, chemically, is the molecule of pursuit.
The molecule of pursuit.
It is the biological engine of craving, novelty, and anticipation. It compels you to look outside the confines of your own skin, to seek out resources, to hunt, to achieve. It is the friction of desire. When you get a hit of dopamine from social media, the pleasure isn't the fulfillment. The pleasure is the addictive anticipation of what the next scroll might reveal.
So dopamine is basically go, go, go. And what blew my mind in the research is the structural relationship between dopamine and adrenaline. They aren't just in the same neighborhood, they're on the exact same assembly line.
They are biologically intertwined. Dopamine is the biochemical precursor to epinephrine.
Like literally, your body manufactures adrenaline out of dopamine.
Yes. Through a specific enzymatic pathway, dopamine is converted into norepinephrine, which is then converted into epinephrine. This is why dopamine is so incredibly powerful for elite performers. When you generate dopamine, you aren't just getting a psychological boost of motivation, you are synthesizing the raw chemical ingredients that will literally convert into the physical energy required to keep moving.
This completely demystifies how people survive the most impossible, grueling scenarios. It explains the concept of milestoning. The sources use the incredible example of Marcus Luttrell, the author of Lone Survivor.
Right.
He is a Navy SEAL whose entire team is killed in a catastrophic ambush in the mountains of Afghanistan. He's severely wounded, practically paralyzed from the waist down, and miles away from extraction. If his brain looked at the macro picture, I have to crawl 7 miles with a broken back, the limbic friction would be insurmountable. The dopamine system would crash, and he would die.
Yeah.
So what does he do? He shrinks the aperture of his pursuit.
He fundamentally hijacks his own autonomic nervous system. Luttrell didn't try to crawl miles. He looked at a rock that was perhaps 5 feet away. He drew a line in the dirt with his knife, and he set a singular micro goal. I am going to crawl to that rock.
And when he reaches the rock, there is no crowd cheering for him. There is no external reward. But the internal process is what matters.
By setting a milestone just outside his current comfort zone and successfully reaching it, Luttrell allowed his brain to register a win. That internal acknowledgement drips dopamine into the neural circuitry.
Okay.
And because of that biochemical pathway we just discussed, that dopamine converts into epinephrine, which provides a literal surge of physical energy and alertness, allowing him to focus on the next milestone, a tree 10 feet away. He chained those microdrips of dopamine together to crawl for miles.
It is an internal perpetual motion machine. You manufacture your own fuel by manipulating your goals. But here's a practical question for the listener. If acknowledging a win creates dopamine and energy, shouldn't I just constantly reward myself for every tiny thing I do all day long?
Intuitively, yes, but neurologically, no. If you reward every single tiny victory, you eventually run into a problem with receptor downregulation. The brain habituates to a constant, predictable stream of dopamine, and the molecule loses its motivational potency.
So it stops working.
Right. To keep the machine running optimally, you have to introduce uncertainty. Behavioral science and computer modeling have identified an optimal schedule for reinforcement, the 85-15 rule.
How does that look in practice for someone trying to learn a language or start a business?
It means that you should strive for a failure rate, or a lack of internal reward, about 15% of the time. When you are pursuing a massive goal, you set your micro milestones. Roughly 85% of the time you hit one, you should pause, internally acknowledge the win, and let the dopamine release.
Okay, celebrate most of them.
But randomly, about 15% of the time you hit a milestone, you should intentionally withhold the internal celebration. You just push right past it onto the next task, offering yourself no psychological pat on the back.
That seems harsh. Why deprive yourself?
Because intermittent, unpredictable reward is the most highly motivating schedule for the mammalian brain. It is the exact same psychological architecture that makes slot machines and social media so brutally addictive.
Oh, like a casino.
Exactly. You don't know exactly when the dopamine hit is coming, so the brain stays intensely, hyper-vigilantly locked into the pursuit. By applying the 85-15 rule, you are ethically weaponizing casino psychology to build your own relentless resilience.
Okay, if our internal narrative, whether we choose to celebrate a rock in the dirt or withhold a reward, can literally dictate the chemical release of dopamine and adrenaline in our blood, that leads us into deeply weird territory. Can our thoughts and expectations fundamentally alter our physical, mechanical reality?
This is perhaps the most profound area of modern physiological research. The science of the expectation effect, heavily pioneered by researchers like Dr. Ali Crum at Stanford, proves that psychology and physiology are not separate disciplines. They are intimately mechanically braided together.
We have to talk about Dr. Crum's milkshake study, because when I read this in the sources, I had to read it 3 times. It sounds like science fiction. Break down exactly how they set this up.
The brilliance of the study is in its simplicity and its deception. Dr. Crum and her team brought a large group of participants into a lab and gave them a milkshake to drink. But they split the participants into 2 distinct groups and manipulated the narrative.
Okay.
They handed the first group a shake branded as indulgence. The label loudly proclaimed it was a decadent, incredibly rich, 620-calorie dessert shake.
A total dietary bomb.
Exactly. They handed the second group a shake branded as Sensi Shake. The label claimed it was a sensible, zero-fat, nutrient-dense diet shake containing only 140 calories.
But, and this is the crucial part, what were they actually drinking?
Both groups were drinking the exact same 380-calorie milkshake. The physical inputs were identical. The only variable was the expectation constructed by the label. After the participants drank the shakes, the researchers didn't just ask them how they felt. They drew their blood to measure their physical endocrine response, specifically focusing on a hormone called ghrelin.
Ghrelin is the hunger hormone, right?
Correct. When your stomach is empty, ghrelin levels rise, signaling the brain that you need to seek food. When you consume a heavy meal, ghrelin levels plummet, shutting off the hunger drive and signaling profound physiological satisfaction.
So what did the blood work show?
The group that believed they drank the 620-calorie indulgence shake experienced a steep, dramatic drop in ghrelin. Their digestive biology reacted as if they had consumed a massive caloric load.
Even though it was only 380 calories.
Right. The group that believed they drank the 140-calorie diet shake experienced a relatively flat ghrelin response. Their bodies registered that they had barely eaten, and they remained physiologically hungry.
Their blood chemistry altered itself based on a graphic design label. That is not a placebo effect where someone just feels a bit better. Their actual digestive hormones metabolize the exact same food differently because of a belief.
What's fascinating here is how the real physiological response is braided together with our psychological expectation to create our physical reality.
And if that isn't crazy enough, the expectation effect can literally override your DNA. Tell me about the carbon dioxide genetic study.
This study takes the concept from digestion into elite performance. Researchers brought in participants and ran them through strenuous cardiovascular testing on treadmills to establish their baseline endurance and their ability to clear carbon dioxide. During the intake, they swabbed the participants' cheeks for genetic testing.
Okay.
They were ostensibly looking for a specific rare genetic mutation that naturally endows a person with superior oxygen processing and CO2 tolerance.
A genetic superpower for athletes.
Exactly. But here's where the manipulation occurs. The researchers took the genetic result and completely lied to the participants.
Of course they did.
They randomly divided them into groups. They told some people, congratulations, you have this elite genetic mutation. They told others, unfortunately, you do not possess the trait. This information was entirely disconnected from their actual DNA.
So you have some people who actually have the superpower but are told they don't, and normal people who are told they are mutants. What happened when they put them back on the treadmills?
The expectation utterly dominated the underlying genetics. When they retested the participants, the individuals who were told they had the superior trait, even if their actual DNA was average, exhibited massive improvements in performance.
Just because they believed it.
Yes. They had lower heart rates at the same exertion levels, they cleared CO2 more efficiently, and their lactate thresholds improved. Conversely, the individuals who genuinely possessed the elite genetic mutation but were told they didn't actually saw their physiological performance degrade.
The belief outperformed the actual DNA.
So wait, I have a massive pushback here. If expectations dictate our physiology to this degree, where is the limit? Like, if I want to run a sub-3-hour marathon, can I just lie to myself, tell myself I'm an Olympic Kenyan runner, and my body will magically synthesize the endurance?
No, you cannot. You cannot outlie your nervous system with pure delusion. If you walk into a desert and use the expectation effect to tell yourself you don't need water, you will die of dehydration.
Okay, good to know.
Dr. Crumb's work does not suggest that belief replaces physical reality. The equation is that real physiological inputs plus your perceived expectation equals your biological reality.
So you can't invent a lie, but you can curate the truth.
Precisely. You must select which true subset of information you allow to drive your autonomic response. Consider intermittent fasting. If you focus on the truth that I have not eaten in 16 hours, I'm depriving myself, this is a form of starvation, your brain will perceive a threat.
Right.
It will spike cortisol, it will increase ghrelin, and you will feel lethargic, irritable, and miserable. But there is an equally true alternative narrative.
Yes. You can focus on the scientifically accurate truth that fasting taps into ancient evolutionary energy systems. It triggers cellular autophagy, clears out waste proteins, and forces my body to burn fat for fuel.
Which is also totally true.
Exactly. If you deeply anchor into that expectation, your brain interprets the lack of food not as starvation, but as a challenge. It releases dopamine and epinephrine, making you feel hyper-focused, energized, and clear-headed. The physical input, no food, is identical. The hormonal cascade is entirely dictated by the expectation.
It is all about where you point the spotlight of your belief. And this is exactly the secret of the Navy SEALs. When Dr. Crumbs studied SEAL recruits, she found a universal, deeply embedded expectation among them. They believe fundamentally that stress grows you.
Yes.
When you genuinely adopt the belief that limbic friction is the mechanism for personal expansion, your body metabolizes the cortisol and adrenaline differently. Hardship stops being a destructive, corrosive force and becomes an organizing, empowering one.
However, we must introduce a heavy caveat here.
Okay, what's that?
We have spent the bulk of this deep dive discussing how to conquer physical stress. How to survive ice water, extreme heat, and endurance events. But for the vast majority of people listening, the most devastating, system-crashing trauma they will ever face is not a VR shark or a grueling marathon.
Right.
It is the sudden severing of a profound human bond.
Heartbreak, a divorce, a catastrophic breakup, or the death of someone we deeply love. How does the autonomic nervous system handle the limbic friction of that specific emotional trauma? Because you can't just ice bath your way out of grief.
You cannot, because the neurobiology of grief operates on an entirely different mapping system. To understand why heartbreak physically hurts, we have to look at how the brain encodes relationships. When you fall in love with someone or form a deep attachment, your brain anchors them into your subconscious architecture using a three-pronged mapping system.
The tripod of attachment.
Yes. The first prong is space. Where are they physically located right now? Are they at work, in the next room, across the country? The second prong is time. When will I see them next? Will they be home at 5 p.m.? The third prong is closeness or attachment depth. How heavily do I rely on this person to regulate my own autonomic nervous system? How deeply do I trust them?
Space, time, and closeness. And the brain uses specialized cells to track this, right? The sources mentioned place cells.
Exactly. The hippocampus utilizes place cells and grid cells, the same navigational neurons you use to map out a grocery store to map your emotional relationships. Your brain constantly updates these coordinates to maintain a sense of security. Now, imagine you receive the phone call that a loved one has died, or you go through a sudden, devastating breakup. That tripod is violently shattered.
The map is completely broken.
The brain is thrown into profound confusion. Let's look at the prongs. Where are they in space? They might be in a cemetery, or they might have moved to a new city. When will you see them in time? The agonizing answer is never again. But the cruelty of the nervous system is that the third prong, the deep closeness and autonomic reliance, does not shut off. It remains fully active, fully vibrating, demanding connection.
You are completely untethered. You have the intense desire for the person, but no coordinates for how to reach them. And this leads to a neurobiological reality that completely changed how I view mourning. Grief is not a passive state of sadness.
This is one of the most vital insights from neuroscience. We view grief as a state of lethargy, of shutting down. But brain imaging reveals that grief is actually a highly motivated state of severe autonomic arousal.
Wait, really?
Yes. The neural circuitry activated in a grieving human is nearly identical to the circuitry activated in a starving animal that can smell a piece of food just on the other side of an impenetrable wall.
Oh, wow.
It is an intense, driving, dopaminergic desire to bridge the distance in space and time to reunite with the object of attachment. But in the case of death or a permanent breakup, that distance is physically impossible to bridge.
You are flooded with all this energy, this agonizing drive to go find them, but there is nowhere to direct the energy. Which immediately makes me think about how catastrophic modern technology is for this remapping process.
Oh, absolutely.
Navigating a breakup in the era of social media must be the absolute worst possible environment for a grieving brain.
It is neurologically torturous. In order to heal, the hippocampus must do the painful, exhausting work of remapping. It has to accept that the person is gone in space and time and slowly allow the closeness motivation to extinguish. But what happens when you check your ex's Instagram story?
You see exactly where they are in space. They're at that coffee shop downtown.
Precisely. And you see them in time. The timestamp says 5 minutes ago. By engaging with that digital footprint, you are providing your brain with false coordinates. You are keeping them alive and accessible in the map.
Wow.
You are staring at the food through the glass wall, constantly re-triggering the motivational drive and completely stalling the brain's ability to sever the attachment. You are artificially renewing the trauma every single day.
So what does this all mean? The absolute non-negotiable first step of healing is no contact. You have to remove the digital coordinates so the brain is forced to accept the void and rebuild the map. But I want to push back on how we handle that massive energy of grief. Because in pop culture, and especially in high-performance communities, there is a massive trope about weaponizing heartbreak.
Sure.
We hear about the musician who gets dumped and channels all that rage and grief into writing a masterpiece album, or the guy who uses a breakup as fuel to hit the gym twice a day, work 100-hour weeks, and become a millionaire. Isn't sublimating that grief into extreme output a highly effective strategy for elite performance?
It is a remarkably common strategy, and it will absolutely propel you forward in the short term. When you sublimate grief, anger, or resentment into work, you are taking that massive autonomic arousal, that narrow soda straw aperture of focus, and you're pointing it like a laser at a career goal or a physical target. But I would offer a very stark warning about its long-term viability. It is a dangerous illusion.
Why is it an illusion? If they're getting the money, the promotions, the physical fitness, isn't it working?
It appears to be working externally because society rewards the output. But internally, what are they actually doing? They are using the exhaustion of the work to run away from the pain of the remapping process.
Right.
They are refusing to sit still with the autonomic sadness. They are terrified to let the mind map the reality of the loss, so they just keep the engine redlined in park.
They are carrying around a broken map, but driving so fast they don't have to look at it.
Exactly. And the autonomic cost of that is catastrophic. Using anger or unhealed trauma as your primary fuel source is like trying to drive a high-performance supercar with a gas tank that is riddled with leaks.
Leaky fuel.
Anger is incredibly energetically demanding. It requires constant sympathetic arousal, which floods the body with cortisol, suppresses the immune system, and fundamentally disrupts sleep architecture. If you rely on the grind set of weaponized trauma, you look incredibly successful. But 5 to 10 years down the line, you will inevitably hit a wall of profound adrenal burnout. You will be exhausted, sick, and wondering why your life feels totally empty.
So if anger, spite, and unhealed grief are ultimately toxic, leaking fuels that guarantee a crash, what is the alternative? If a listener wants to sustain an elite, highly demanding, high-output life for decades without destroying their nervous system, what do they put in the gas tank?
This requires a fundamental shift in how we approach limbic friction. Let's look at a modern example from the sources.
Right.
Lex Fridman. He is an AI researcher, podcaster, and a black belt in jiu-jitsu. He is renowned for an almost superhuman, grueling work ethic. The sources likened him to a wolverine, this relentless, solitary, wildly strong creature. But if you listen to Lex's stated philosophy for how he approaches his massive workload and his interactions, he constantly talks about approaching the world with love in your heart.
I've always found that fascinating. Love in your heart sounds almost aggressively soft for a guy who trains in combat sports and grinds out complex code all night.
It sounds soft emotionally, but biochemically, it is the most efficient, sustainable fuel source that exists. When you operate from a place of genuine desire, curiosity, and love, you are balancing the autonomic seesaw.
So.
You have the sympathetic drive to pursue the goal, but it is anchored by a profound parasympathetic calm and connection. You aren't forcing the engine to run on cortisol. You're running on a clean, renewable neurochemical balance. It is an energy source that is essentially infinite.
It's the difference between forcing yourself to run a marathon because you hate your body and want to punish it, versus running a marathon because you genuinely love the feeling of exploring your physical limits. The physical output is the same, but the internal biological wear and tear is entirely different.
Which introduces our final overarching concept, limbic resonance. We do not just regulate our own internal mixing boards. Our nervous systems are deeply, wirelessly connected to the nervous systems of the people around us.
Through mirror neurons and subconscious cues.
Yes, extreme emotional states exert a massive gravitational pull. When you are around someone who is chronically angry and stressed, your system will begin to match their sympathetic arousal. But when you share a resonant, connected experience with someone, it triggers a massive release of dopamine and oxytocin.
This perfectly explains why time feels so subjective. When you're on a phenomenal date, deeply connected and flooded with that resonant dopamine, 3 hours feels like 20 minutes. But when you are sitting in a sterile doctor's waiting room, starved of dopamine and completely disconnected, 10 minutes feels like 3 hours.
Dopamine actively alters our perception of time. And understanding limbic resonance is crucial for how we motivate ourselves and the people we care about. Normally, when we try to motivate a friend or an employee, we rely on 2 basic toggles, reward and punishment. We give them a treat when they succeed, or we reprimand them when they fail.
Which works, but it's limited.
It is very limited. But there is a vital third toggle that leverages everything we've learned today about dopamine and expectation. The carrot on a stick, or the anticipation of future refinement.
I love this concept. How does it work in a real-world scenario?
Let's say a colleague gives a major presentation. If you just say, "You did great," that's a reward. The dopamine spikes and drops. If you say, "You really messed up the third slide," that's a punishment. You spike their cortisol and trigger the soda straw defense mechanism.
Right.
But if you use the third toggle, you say, "That presentation was fantastic, but imagine if next time you incorporated this specific new data point, your argument would be completely unstoppable."
Oh, that is brilliant. You aren't punishing them, but you are actively hanging a potential dopamine reward just out in front of their nose for the next attempt.
Yeah.
You are triggering their molecule of pursuit.
You are providing a milestone just outside their comfort zone, keeping them motivated and moving forward without breaking down their autonomic balance. And you can apply this resonance to yourself by finding the right mentors.
And they don't even have to know they are your mentor, right?
Yeah.
You can borrow the regulation of an author or speaker.
Absolutely. By deeply studying someone whose autonomic balance you admire, whether it is mimicking the rigid, time-blocked discipline of Tim Ferriss or internalizing the calm, philosophical observations of Robert Greene, you are externally borrowing their limbic regulation. You use their systems as a scaffold until you build the thick neural pathways to sustain that regulation yourself.
So, to synthesize this massive journey we've been on, mastering human biology is not about sitting quietly in a room, desperately trying to think your way out of stress. It is not about pretending fear doesn't exist. It is about actively stepping up to the control panel of your autonomic nervous system.
Exactly.
Whether you are stepping into a freezing ice bath to intentionally self-evoke limbic friction, leveraging the expectation effect to literally recode how your digestive hormones and genetics respond to hardship, or bravely sitting still without your phone to map the agonizing geography of grief, you have profound mechanical control over your internal landscape. You don't have to be a victim to the seesaw.
We have covered immense neurological ground today, but I want to leave the listener with one final provocation to mull over. We discussed at length how setting a milestone just outside your comfort zone, and crucially, taking a moment to internally acknowledge it, triggers a chemical drip of dopamine that converts into adrenaline, giving you the actual physical energy to push further. So I want you to look at your life right now. What is a massive goal, a career project, or a physical pursuit that you have been starving of dopamine because you arrogantly refuse to celebrate the micro steps?
Wow.
You likely think you are being tough on yourself, holding yourself to an elite standard by withholding the reward until the absolute finish line. But what if that is the exact biological error that is making you exhausted? What if the key to unlocking elite, relentless endurance isn't punishing yourself more, but simply allowing your brain the neurochemical permission to register the wins you are already achieving?
That is a profound question to end on. Stop starving your engine.
Yeah.
Thank you so much for joining us on this deep dive. Go celebrate a micro step today, and we will catch you on the next one.